70% of Earth is water. However, only 0.00% of this water is drinkable. This percent gets reduced all days because of contamination, and for this reason, more than 1.1 billion people in all the world can get access to this drinking water. Hi, my name is Juan David Valencia, and I'm going to talk to you about removal of pharmaceuticals from drinking water. So, what's the problem? The problem is a group of contaminants present in water called emerging contaminants. This group of contaminants are not regulated because they are only a few they only have a few years of investigation, but they find that they have a lot of negative impacts in the environment, human and animals. They have a lot of categories like pesticides, pharmaceuticals, drug of abuse, hormones, and a lot of more categories. And in this case, I want to talk about one specific category called endocrine disruptive compounds. They alter the functions of the endocrine systems, and they have a lot of issues related like obesity, diabetes, alterations in the immune systems, and a lot of types of cancer like mammal cancer, testicle cancer, and a lot of more. In this case, I take two examples of pharmaceuticals from this group of endocrine disruptive compounds called ibuprofen and ethinyl estradiol. This pharmaceutical, ibuprofen, is a pharmaceutical that the doctor gives you when you have headache, and the ethinyl estradiol is a feminine hormone that is not natural, that it's present in all the anticonceptive fields, and these pharmaceuticals are present in a list of the Environment Protection Agency of the United States called CCL3. That is a list of components present in water that have some issues related, but they don't have any regulation. And why they are important? They are important because in low concentrations they are toxic. For example, for this ethinyl estradiol, it's bad in low concentrations since 0.7 nanograms per liter. It's a really low concentration, and that's why it's important to remove it. They find both both pharmaceuticals in rivers, lakes, in the water of the house, in the water from the bottles that you find in all the markets, and in water treatment plants in all the world, like in China, Brazil, and a lot of more countries. So what's the solution from this problem? Well, I want to present two possible solutions for this problem, and they are activate carbon, that it's crushed carbon that you can see here, and I'm going to show how it works. So we have the activate carbon, and if we make a zoom, we can see this. These are the pores of the activate carbon, and these cycles are the organic compounds like the pharmaceuticals. So the activate carbon can take these pharmaceuticals in their pores, and they catch it, and after that we could remove the activate carbon from the water, and we remove at the same time the pharmaceutical because it's catch in the activate carbon. The other solution is advanced oxidation problems (AOP) that are a process using UV light, and it works like this. We have the UV light and we use hydrogen peroxide that it's um, well chemical that with the UV light they can make that the pharmaceutical broke with an action called photolysis, and we with this process the pharmaceutical get degraded and they basically they are broke. So we use this process to broke and remove the pharmaceutical from water. So how to implement it? Well, we can put the system in the water treatment plants in Bogota, and it's really easy. We in the front of this we can put the activate carbon, or if we want to put the AOP system, we can make another room with the light and we put the peroxide hydrogen and we can remove the pharmaceuticals from water. Well, this process have a lot of problems because we need to pay money for that, but I think that the money that are related to the patients that have the issues related to the issues related to the pharmaceuticals present in water are bigger than the cost of the system, and we need to help people. So I think that it's better to put the system than well have sick people, and that's it.